All right, welcome everybody. Today we are going to spend a second day talking about section 4.3, division of polynomials, but instead of using long division, we're going to use a technique called synthetic division. If you think in general what the word synthetic means, it kind of means a fake or essentially a shortcut of some kind. So you are going to think of synthetic division as being a shortcut for long division. So that's the good news, is that most people find this to be easier than long division. The bad news is that it only works in a limited number of cases. And so in order for synthetic division to be an option, it means that the divisor has to be linear, which means it can only be of the form x minus k or x plus k, meaning that it can only be x to the first power. So again, x to the first power, x to the first power. So if you were to go back to the long division homework from yesterday, as long as you had a divisor that was linear, you could use this technique and you would 100% get the same answer. For any problem that had a divisor that was not linear, you would not be able to use it, which means long division would be your only option. One of the most important things you have to know about synthetic division is that you have to take whatever the factor is that you're given, the divisor, and you always have to take the opposite. So if you had x minus k, you would actually plug in positive k. If you had x plus k, you would actually plug in negative k. Another way of thinking about that is you're going to set the divisor equal to 0 and solve for x. So you can do that step if you need to, or if you're able to just remember to take the opposite, that will work as well. If you take a look here in the top right, I've already done one problem all the way through for you, and then we'll obviously do a bunch together. But just to kind of get you started, here's the problem to begin with. You are being asked to divide 2x to the third minus 5x squared minus x plus 3, and you're being asked to divide it by x plus 3. Now, the problem might say divide however you want, or it might specifically say use synthetic division. So the first thing you have to do is you have to take the divisor, which is x plus 3. You can set it equal to 0 and then solve if you want to, or again, just think of it as the opposite. So if x plus 3 is the divisor, you're going to plug in negative 3. Where are you going to plug it in? Well, you're going to put it here on the left-hand side. Then you're going to take a look at your cubic polynomial, and you are going to copy the coefficients only and set up them in a row. So the 2 from the cubic, the negative 5 from the quadratic, the negative 1 from the linear, and then the 3 that's a constant. Once you have reversed the sign of the divisor and set up the coefficients, here is the procedure. Step 1, you are going to take whatever the first number is out front, and you are going to just bring it down to the first slot. Then you are going to take that value and you are going to multiply it times that negative 3. You're going to take that value, negative 6, and you're going to add it into the next column. Then you are going to add that column for an answer of negative 11. Then you're going to multiply that negative 11 times the negative 3. You're going to get a positive 33. You're going to put it in the next column. Then you're going to add that column. You're going to take that 32. You're going to multiply it times the negative 3. That's going to give you a negative 96, which goes in the next column. You're going to add that column for a final slot answer of negative 93. Once you've done all that work, you now have to take a look at the values in the bottom row, and you have to rewrite that as a polynomial. So whatever is in the final slot is always, always, always going to be the remainder. And then the other rule is whatever value of the exponent you start with, in this case 3, your answer is always going to start 1 less. So because this problem started off as a cubic, you're going to take the first coefficient of 2, and you're going to go to the 1 less power, which would be x squared. Then the negative 11, you're going to make that a linear, which is an x. The 32 is going to be your constant. And then remember, you still have to give your answer in that same format, the quotient plus the remainder over the divisor. So your quotient is that quadratic. Your remainder is negative 93 divided by x plus 3, and this is your final answer or your final solution. I promise you, if you were to do this procedure using long division, you would absolutely get the same answer. Maybe you like this better, maybe you think it's equally difficult, but the truth is, you do have to know how to do both methods. So again, there's one that's kind of already done for you. So now let's do some together. So Take a look here. It is specifically telling you to use synthetic division. For tonight's homework, please make sure you follow that. You want to make sure that you know how to do both methods. Remember, of course, that your answer should be in the correct form. Taking a look at number 1, taking a look at number 2, notice that 1 is given to you in terms of with a fraction bar, where the other is given with the division symbol. You're going to approach them the same way. I just wanted to show you multiple starting formats. So here is how we are going to approach this. You are going to start by taking the coefficients of the dividend, and you are going to write the coefficients only. So positive 3, negative 2, negative 7, and positive 6. Personally, I like to draw a little box, and then I like to draw a line. The next order of business is to determine what's going to go in that box. To determine what goes in that box, you're going to look at the divisor, in this case, the denominator, and you're going to take the opposite. If you don't like the idea of just saying the opposite, you would set it equal to 0 and then solve. But either way, negative 1 is going to be the number that you put in the box. Now that you have set up everything you need, you're going to go ahead and use the process that I showed you previously. So step 1, always bring down the first coefficient, which in this case is a 3. Multiply to the box. So 3 times negative 1 is negative 3. Add the column, negative 5. Multiply to the box, positive 5. Add the column, negative 2. Multiply to the box, positive 2. Add the column, 8. You know that you're done when you've run out of columns to choose from. In order to write your answer, you have to go back to the original leading term, and you have to identify that degree, which is a cubic. That means you're going to start the first coefficient to the 1 less power. So this is going to be 3x squared minus 5x minus 2 as the constant, and then plus 8 over x plus 1. Remember, that is the remainder over the divisor, and that is just the format that we have to give our answers in. And of course, you'll notice it's the same format as yesterday. So that was your first synthetic division problem. The main difference between this and long division is that in long division, remember, you were always subtracting, draw the line, change the sign. Here in synthetic division, you're always adding. And the reason why that works is because you change the sign here in the box. That's why you're allowed to add instead of subtract. So let's go ahead and try another one here in number 2. If any of the terms don't have a number in front, you're of course going to assume that there's a 1 there. So when I go to copy my coefficients, I'm going to do a 1 for the cubic, a negative 5, followed by a negative 6, and a negative 2. Then you're going to take the divisor. You can either simply take the opposite. So the opposite means if it's x minus 3, you're going to choose positive 3 and put it in the box. Draw a line. Remember, if you can't remember to take the opposite, you're going to set it equal to 0 and then solve. Now we're going to go ahead and follow the steps, which again, after you do just a couple of these, they almost become muscle memory. So bring down the 1. 1 times the box, 1 times 3 is 3. Move it to the next column. Add that column, negative 2. Multiply to the box, negative 6. Negative 6 plus negative 6 is negative 12. Multiply to the box, negative 36. Add the column, negative 38. Now, of course, I'm able to do these calculations in my head, but you should feel free to use a calculator as needed. For your answer, again, identify what the degree of the original problem is, and then you're always going to start with 1 less. So that's going to be a 1x squared. You can put the 1 or not. It doesn't matter. Minus 2x minus 12 plus negative 38, which is the remainder, over x minus 3. Also remember from yesterday that instead of doing plus a negative, you could also just take the minus and put it out front and then do 38 over x minus 3. Both of those are perfectly acceptable. How about number 3? So actually number 3 is even easier than the first two because you're only starting with a quadratic. But again, let's start by looking at our dividend. We're going to go ahead and copy those coefficients, 7, negative 3, 5. Take your divisor. Either set it equal to 0 and solve, or simply take the opposite, negative 2. Once you've got your setup, you're going to go ahead and bring down the 7. Multiply, oops, forgot my little box there. Bring down the 7. Multiply it times the box, which is -2, so that's -14. -14 plus -3 is -17. -17 multiplied to the box gives you +34, and 34 plus 5 is 39. Notice that in this example, you started off just as degree 2, which is a quadratic, which means your answer is just going to talk about being a linear. So that 7 is going to be 7x minus 17 plus 39 over x plus 2. And again, that is the proper format that you have to give your answer in. So far, we've had 3 examples, all of which have a remainder other than 0, which means so far, none of these polynomials have divided evenly. Yes, it's nice when they do, but perfectly fine that they don't. And then in number 4, we hit a little bit of a roadblock here. Maybe it's not obvious right from the start, but as you take a look at your dividend, maybe it sticks out at you that you're going right from x to the 4th to x to the squared, which means you are missing something with x to the 3rd. So if you remember the long division lesson, when that happened, we had to use a placeholder, and it turns out it's the same exact scenario now. So we're going to go ahead and copy the 3 coefficient. Then, because of the fact that there is no 0, this is essentially a 0x cubed, which means we're going to need a 0 placeholder. Then we're going to need a -5 for the quadratic, a +7 for the linear, and a 2 for the constant. Take your divisor, either take the opposite or set it equal to 0. -1 goes in the box. Once I've got the setup, you're going to go ahead and follow the same procedure. And again, treat the 0 just like you would any other number. Multiplying by 0, of course, gives you a 0. So bring down the 3, multiply to the box, -3. -3 plus 0 is -3. -3 times -1 is +3. +3 plus -5 is -2. -2 times -1 is +2. 7 plus 2 is 9. 9 times -1 is -9. 2 plus -9 is -7. Because of the fact that you started off in this problem being to the 4th power, that means your answer is going to start off always 1 degree less, which means 3x to the 3rd minus 3x squared minus 2x plus 9, and then plus -7 over x plus 1. So just like long division, it takes no time at all to put that placeholder in, but you do have to make sure that you do it, or else everything is not going to line up perfectly accurately. Just so you're aware, not only can you have one placeholder, but you can actually have multiple placeholders. So let's go ahead and see a couple that are like that. So take a look here at number 5. So in number 5, as you take a look at your dividend, notice that you are again missing the cubic term. So that means that there's essentially a 0x cubed. It's not always the cubic term that's missing. It just happened to be in these 2 cases. So go ahead and copy your coefficients. -x to the 4th would be -1. 0x cubed, 3x squared, -6, and -2. In the box, if you take a look at x minus 4, you're going to go ahead and do the opposite, which is +4. Let's go ahead and see what happens. So bring down the -1 times 4 is -4. 0 plus -4 is -4. Times 4 is -16. -16 plus 3 is -13. Times 4 is -52. Plus -6 is -58. Times +4 is -232. And if you add those together, you get -234. Remember I mentioned yesterday that remainders can literally be anything, positive, negative, 0, big, or small. So no worries, whatever it happens to be. Go ahead and take a look that because this started off as the 4th power, you're going to start off to the 3rd power. So -x cubed, remember put the 1 or don't put the 1, it doesn't matter. Minus 4x squared minus 13x minus 58 plus negative 234 over x minus 4. Now, again, I imagine you probably are liking this method a lot more than long division. You are ultimately on a test or quiz going to have to do both. So now that you've learned synthetic, don't disregard long altogether, but certainly for tonight's homework, synthetic division will be the focus. And then one final problem here in number 6. Take a look here, x to the 4th minus 16. Well, if you take a look at that, we are missing not just one term, but a ton of terms. So we essentially have a 0x cubed, a 0x squared, and a 0x. So we have not just one placeholder, but we're actually going to have 3 placeholders. So we're going to start off with a 1x to the 4th, a 0 for the cubic, a 0 for the quadratic, a 0 for the linear, and then a negative 16 for the constant. Draw your box, draw your line. Take a look at the divisor, x plus 2. You're going to go ahead and put a negative 2 in the box. Hopefully, again, muscle memory at this point, you've got the steps down. You're going to bring down the 1. Times negative 2 is negative 2. Negative 2 plus 0 is negative 2. Negative 2 times negative 2 is positive 4, plus 0 is 4. Multiply to the box, negative 8. Add the column, negative 8. Multiply to the box, 16. And would you look at that? We finally got a remainder of 0. We just kind of like when that happens. It just feels a little bit nicer. For our final answer here, again, because we started off to the 4th power, we're going to start off our answer with a 1x cubed minus 2x squared plus 4x minus 8. Because of the fact that the remainder is 0, that means we don't have to do plus the remainder over the divisor. You could if you wanted to, but again, because it's 0, we tend not to do that. So everything on this front page here was all about dividing with synthetic division, and now we're going to talk about a second application of synthetic division on the back. All right, so now that we have mastered the concept of synthetic division, here is another application of it. The second application of synthetic division is by using something called the remainder theorem. The remainder theorem is kind of a mouthful, and what it says is that if you divide some polynomial f by some divisor x minus k, then the remainder r is equal to f of k. Now again, that sounds really long and complicated, but I promise you that it's not. So let's take a look first at the directions. Notice that the directions are different than they were on the previous side. Use synthetic division and the remainder theorem to evaluate the function for the indicated value of x. So the first thing I'm going to do is I'm going to show you how we would have done these problems prior to this lesson. In number 7, you are trying to evaluate that f function at the value x equals 1. So draw yourself a little arrow up here to the white space. What they're asking you to do when they say evaluate this for x equals 1 is they're asking you to find f of 1. Well, we've done plenty of those. Go to the function. Anywhere there's an x, put a 1. So we're going to do 1 cubed minus 4 times 1 squared minus 7 times 1 plus 10. 1 cubed is 1 minus 4 minus 7 plus 10. 1 minus 4 is negative 3, minus 7 is negative 10, plus 10 is 0, which means that f of 1 is equal to 0. So that is true. That's a perfectly valid way of calculating values at given x's, but turns out there's a different way, and a lot of times what's considered to be a better way, and that's to use synthetic division and the remainder theorem. So if you take a look at number 7, notice that first I took all my coefficients of my dividend and I went ahead and copied the coefficients just like I did on the previous slide. Notice that the main difference here for these problems is that for the value of x, it's an equal to. So because of the fact that it's an equal to, you are not going to change the sign. So whenever you're doing so for these problems, don't change the sign. They're x equals. If they're x equals, that means that's it. That is the magic value that goes in the box. Once you have copied the coefficients and once you've decided what goes in the box, well, now you're ready to perform the procedure just like we did on the previous page. Bring down the 1, times 1 is 1, plus negative 4 is negative 3. Multiply to the box, add the column, multiply to the box, and you get a 0. Here's what the remainder theorem says. If you don't want to go through all the trouble of what I did in the white space of plugging the value in, the remainder theorem says you can do synthetic division, And whatever you get in the remainder slot, which is at the end, has to be equal to whatever you would have gotten if you just straight up plug the number in. So not only is there a slight difference here in what you put in the box, remember you only put a 1 in, you did not change the sign. The second difference is your answer. Your answer you should write as following: whatever the function is called, in this case f, of whatever value you were asked to evaluate it of, which is 1, equals whatever the remainder is, and that is your answer. That is your answer only. Because the question does not say divide, you're not actually finding a quotient and all that stuff. All you're doing is using the remainder theorem to evaluate at that specific value. So take a look at number 8. In number 8, take a look at the original problem. Notice that because of the fact that there was no quadratic term, I had to use a 0 placeholder, so that is still the case. Then take a look, x equals -3. So if x equals -3, you are not going to change the sign. You're going to just leave it in the box. And then we're good to go. So bring down the 1 times -3. Add to 0 is -3. Multiplies to 9, adds to 0. Multiplies to 0, and adds to -3. For your answer, it's going to be f of whatever value they gave you, which was -3, equals whatever the remainder is, which in this case is -3. And again, that is how you're going to write your answer. Really nothing different for numbers 9 and 10, but let's just do a couple more to make sure. Again, notice that I copied all my coefficients. I needed a placeholder for number 9, but not for number 10. Take a look at the values that are given. Again, because they're giving x equals -2 and -4, go in the box, no switching required. Bring down the -1 times 2 is -2, adds to be -3, multiplies to be -6, adds to be -4, -8, -8, -16, and -22. F of whatever value they gave you equals whatever the remainder is. And one last time, so bring down the 1 times -4, adds to -5, multiplies to 20, adds to 4, multiplies to -16, and you got yourself a 0. So f of whatever they gave you is equal to whatever the remainder is, which in this case is equal to 0. So not only did I split this lesson up, front side, back side, but your homework is really kind of similar. So just make sure that you're reading the directions. If it says divide with synthetic division, do it like the front side and give your answers accordingly. If it says use the remainder theorem, then you're going to do it like such. We're going to finish up with 2 kind of interesting application questions. So in number 11, what is the value of k that makes the given polynomial divided by x minus 5 having a remainder of 0? So they're basically asking you, what does that coefficient have to be in order for the remainder to be 0? So first of all, you could use synthetic or long division. Because of the fact that this is x minus 5, which is linear, synthetic division is allowed, so I would recommend it. Think about how we started all our other problems. We started by copying our coefficients. We're still going to do that, but in this case, one of the coefficients just happens to be a k, so no worries. Then draw a box, draw a line. Notice here, we're back to x minus 5. So this is back to like it was on the previous side. If it's given to you as a parentheses, you do have to set it equal to 0 and then switch the sign or solve, which means you're actually going to put a 5 in the box. So when it's given to you as a divisor, as a factor, you have to switch it. If it's given to you as an equals, then you just leave it. The next piece of information that I know is the fact that the remainder has to be 0. So if the remainder has to be 0, I know that that is what I'm going to get in my final slot here. I'm now going to try to do synthetic division from the front, from the back, and then once the 2 parts match up, I should be able to solve for k. So bring down the 1, times 5 is 5. 5 plus -1 is 4. 4 times 5 is 20. Nothing else I can do there, so I'm going to stop for a minute. Now I'm going to come from the other direction. So from the other direction, in order to figure out what's going to go in this slot here, well, -30 plus what would give you 0? That would have to be +30. In order for this to be positive 30, whatever goes in this slot would have had to be multiplied by 5. So 30 divided by 5, that's how I know that this slot has to be 6. And then I'm going to take this column here, and I'm going to take what I know about synthetic division and set up an equation. According to synthetic division, you're supposed to be able to add the column and have it equal to the number on the bottom, which means that subtract 20 from both sides, k has to equal negative 14. So at its heart, you're still just using synthetic division. Looks a little different, looks a little harder, I agree, but at the end of the day, it really isn't. And then last but not least, here we have a rectangular prism, and they are giving us the volume. They are giving you 2 of the values here, 2 of the dimensions, and they're asking you to find the third one. So this is actually a pretty cool problem, and it actually highlights something that we're going to be doing later in the chapter. Turns out that synthetic division is so great that not only can you do it once, but you can actually do it multiple times in a row. So starting with the fact that this is a cubic, I'm going to go ahead and copy my coefficients, just like always, 2, 17, 46, and 40. Here's the thing. In order to be a dimension, you have to divide evenly into the volume. It wouldn't make sense to have a remainder if you're talking about an actual shape. So that actually tells me 2 things. The first thing that tells me is that because this is x plus 2, I'm going to either set it equal to 0 and solve, or I'm going to flip it. The second thing that tells me is because of the fact that it has to divide evenly, again, just kind of using common sense, that's how I know that the remainder has to wind up being 0. So all we really need to do now is kind of prove that it works. So bring down the 2, negative 4, 13, negative 26, 20, and negative 40. Now we have taken our cubic, which is where we started with, because of the fact that we did 1 round of synthetic division, what we now have here is a quadratic. But because of the fact that we have a second factor here, we're actually going to do a second round of synthetic division, and we're going to do it right underneath. So again, you're going to either set this equal to 0 and solve, or simply just switch the sign. You're going to draw a second line, but you're going to stop under the 20. You're not going to do anything here in this space because the 0 means that round is over. All I have to do now to finish is 1 more round. So bring down the 2 times negative 4 plus 13 minus 20, and I get that second remainder of 0. And again, I actually knew that going in. I know that these should be remainders of 0, because how would you make a shape if each of the sides didn't go in individually? To kind of answer the question, my conclusion, I started off as a degree 3 cubic. Then I did 1 round and wound up as a quadratic. That means that my final answer has to be a linear, which means that the length of this prism has to be 2 linear x plus 5. So there are actually lots of great, fun, and interesting applications of synthetic division, and I promise we're going to see much more in the upcoming lessons. So thanks very much for tuning in, guys, and we will catch you next time.